All right, advent of code, day 16. Here we go. Ticket translation. As you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. However, the train ticket you're given... What? Oh, okay, that's fine. You were given... Whoa. You should probably figure out what it says before you get to a train station after your next flight. You don't understand the language. Can't actually read the words on the ticket. You can, however, read the numbers, and so you figure out the fields these tickets must have and the valid ranges for the values in those fields. You'll collect the rules for ticket fields, the numbers on your ticket, and the numbers on other nearby tickets for the same train service via the airport security camera together into a single document you can reference your puzzle input. The rules for ticket fields specify a list of valid fields that exist somewhere on the ticket and the valid ranges of values for each field. For example, class 1 through 3, 5 or 5 through 7. Okay, they're all or. Good. Inclusive, 3 and 5 are both valid. 4 is not. Each ticket is represented. Okay, I have a bunch of tickets. A single line of comma separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. Text and language you don't understand. You've extracted just the numbers in such a way that the first number is always the same specific field. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Completely invalid tickets. Ignore your ticket for now. Nearby tickets, invalid. Adding together all of the invalid values produces your ticket scanning error rate. 4, 55, and 12. Okay. All right. Rules equals stirs dot each do all right, so grouped stirs 0 dot each do stir. So these are rules. Stir dot split name ranges equals a b range b equals ranges dot split or dot map strip a min a max equals ra dot split dot map to I. B min b max puts no rules name equals a min a max b min b max grouped stirs 1 dot skip 1 dot each do ticket nums equals ticket dot split comma dot map to I. And then we want to error rate equals 0. Nums dot each do num is valid equals true. Rules dot each do values dot each do RB if Are these all? Okay, they're all lower and then higher. So if num is less than RA, 0 is valid equals false break. Or RB 1 is less than num. And then if RA1 is less than num and num is less than RB0, if is valid, error rate plus equal num puts error rate. Skip each. $1,000. Okay, that puts rules name, puts inspect. Okay, zone 37, 338, 353, 960. Okay. Puts RA. Dang it. Incorrect. Nearby tickets. Contain values that are not valid for any field. Oh. Dot any is valid is rule dot values dot all none valid is valid equals false. Or none valid. It's valid if for all of the values the num is less than the first one, or it's greater than the second, or it's between $300. Okay, that'll do. Part 2. Now that you've identified which tickets contain invalid ones, discard those in tickets entirely. Ticket bad equals false. Ticket bad equals true. Valid tickets equals select, not ticket bad. Okay. Using the valid rangers for each field, determine what order the fields appear on the tickets. Okay. Find possible index for field name, valid tickets, rules. Let's find possible index for rules.key is 0, valid tickets, also add grouped stirs.1 1.split.map to I. Okay. Tickets, rules, valid tickets, rules, ticket 0, field rules equals rules, field name, 0 through tickets dot length -1 times do n index I, all vals equals tickets dot map ticket I, if select all vals dot all do n num RA0 less equal num, and num is less than equal RA1. B. Hey, Mom. Put rules.key 0. $54. What are my valid tickets? Oh. Valid tickets dot map. Okay. Okay. So departure location, part 1. Oh, also I forgot to do this. A little late, but whatever. Departure location can be in those values, those indexes. So valid rules at indexes equals hash dot new equals set dot new. Then rules dot keys dot each do field field dot each do I valid rules at indexes I field puts valid rules at indexes dot inspect. Holy moly. Holy cow, this is hard. Well, let's actually use this example. First position must be row, second position. Oh, first position must be row, second must be class. Okay. Okay. Now I somehow need to pick out the right ones from here. Valid rules at indexes dot each do KV puts okay v dot length aha 1. Okay, perfect. Okay. Rules at indexes. Okay. So we want map KV. I think that is unnecessary. Dot sort by KV v dot length index potential rules equals puts rules at indexes. Okay, so it was 2. Okay, equals that. So then index potential rules dot each do index rules each with index I puts index rules. Cool. Rules at indexes if rules dot count equals 1, else put too many choices for index. Then rules at indexes equal index rules to array 0, and then index potential rules I plus 1, 30 dot each do rules set dot remove rule to a. What? Delete? Puts index is rule. EX1. Index 0 is row, class C. Okay. And now, yeah, okay. Depart rules equals that. My ticket equals grouped stirs 1 dot split dot map to I, and then prod equals 1 if part rules dot include rule prod times equals my ticket index puts prod. Boom! 153. I'm pretty satisfied with that. That was a great question. That was a lot of fun. I had a lot of fun. Whew. All right. 153. There we go. Yeah, this question was a lot of fun. I liked this question. Great question. Cool. Let's review. Day 16. All right, day 16. Ticket translation. Let's open up our input. As you're walking to yet another connecting flight, you realize that it's weird that the like theme of this whole contest is just like traveling. which in a way is like the most miserable thing. Not like traveling to a destination. It's just traveling, like getting from place A to place B, connecting flights on ferries. As you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. However, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Unfortunately, you can't actually read the words on the ticket. You can, however, read the numbers. So you figure out the fields these tickets must have, and the valid ranges, the values in the valid ranges for values in those fields. You collect the rules for ticket fields, which is this first part, the numbers on your ticket. This is my ticket, and the numbers on other nearby tickets for the same train service, which you got via an airport security camera, which you for some reason have access to, together in a single document. Great. The rules for ticket fields specify a list of fields that exist somewhere on the ticket and a valid ranges of values for each field. For example, a rule like class 1 through 3 or 5 through 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1 through 3 or 5 through 7, both inclusive, all inclusive. And then every ticket is just a comma separated list of values, and each value, the seventh value in each list always represents the same field. So we have a lot of, wow, departure location, station, platform, track, date, time. Yeah, these do seem like the important ones. So for part 1, we want to determine which tickets are completely invalid, which are tickets that there's some value in this list which doesn't match any of these, and we're ignoring our ticket. So I have this stir group separated by blank lines, which was used on a couple of the early days, which is super useful today. So we first need to parse all the rules, and so going through this first group, these here, we basically split on the colon and then the or and then dash. So the name and the ranges we split on here. Then we get the ranges, splitting on or, and then I strip them just to make sure. And then each range I split on the dash, map everything to an integer, and then I store those in our rules, which is just a hash from rule names to things. So then we go over the second group, or the third group, group stirs 2, which was my initial mistake. And then it has a header for some reason. Oh, this is a good point. Like, it's way easier to just delete this and actually just modify your input rather than modifying your code sometimes. But whatever. So I added this select here for part 2, but basically we have an error rate, and what we need to do for part 1, it doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. For this ticket, all the fields are valid, but on this one, 4 isn't valid for any of these. Yeah. So if you add together all of the invalid values, you get your ticket scanning error rate, which is what you're looking for. So I have error rate 0, and then for each ticket, I get the numbers for the ticket, and then for each of the numbers, it's none of the numbers. Okay, yeah, this I changed slightly because eventually for part 2 I want to know which tickets are valid. wait, yeah. So for each number in the ticket, it's not valid for any of the rules. If for all of them, yeah, this would definitely be alternatively simpler if I said like potentially valid rules.values.any, and then I inverted this condition, which I think I do down here. And then if I said if not potentially valid, this would be cleaner. Alternatively, if not potentially valid. Yeah, this is just like inverting all the conditions. So none of the possible rules are valid if for every single rule it's before. Oh, I also took advantage of all of these. It's all of these four numbers are increasing. So it's basically two ranges that are next to each other, which made stuff easier. Because then I could assume, check whether it's invalid if the num is below the first number in the first rule, or if it's above the second number in the second rule, or if it's greater than the second number in the first rule and less than the first number in the second rule. And if it's not valid, then that number is an invalid number. And so I add it to our error rate, and we print our error rate. Puts yeah, part 2. Cool. So that gives us our error rate. So then for part 2, we've identified which tickets contain invalid values. Discard those tickets entirely. And so that's what I did. That's what this select is. Valid tickets is this. And if one of the numbers was bad, I say ticket is bad, starts as false. And then I select the ones that are not bad tickets. So that gives just valid tickets. And then we need to use the remaining valid tickets to determine which field is which. So we need to determine what order the fields appear on the ticket. The order is consistent between all tickets. If seat is the third field, it's the third field on every ticket, including your ticket. So using all of the tickets, I add my ticket as well. And then I wrote this function, find possible index, which basically says, all right, if we have some field, so like duration, for example, we have a bunch of tickets, and these are the rules. We want to know what possible indexes could have duration, and it can duration could be like index 4 if for every fourth value in the tickets, all of those values fit the ranges. And so I get the rules for the field name, and then for ticket 0.length, this is how many fields there are, and then times to iterate 0 to that value, and then I select them to get the possible indexes are that it could be at. I get all the values at that index, and then if for all of those values, the range for that, all of those values are in between one of the two ranges. So if that's true, then this index could represent that field. And so then that gets filtered into what I get at the end. So I create an array or a hash from each rule, from each index to the possible rules that are valid at that index. So for each rule, which are the fields of my rules array, because if I do puts rules.inspect, this is what rules looks like. It's like arrival station 2, this array. For all of the rule names, I find the possible fields that that rule could appear at, the possible indexes that field could appear at, and then for each of those indexes, I say that that field could appear there. Because what I want to know is like, oh, there are sort of two ways you could go about this. It's like, oh, find rules that can only appear in one place, or find indexes that only have one valid rule. Puts valid indexes equals valid indexes dot each puts field valid at valid indexes dot inspect. Okay, interesting. So I could have done this either way, which is basically, yeah, zone is only valid at 12, price is only valid at 8 and 12, and so zone has to be at 12, then I can remove it from here, so price has to be at 8, then duration is at 3, 8, and 12, and so the duration has to be at 3. So it's clearly been constructed that way. But I sort of like then invert it, which is, I don't know if this is really easier. So then, yeah, I basically then invert it. And so, or I take it this, I take this map from each index to things that can appear at that index. And then I convert that to an array of key value pairs. And I sort that array by the size of the set, which is the value pair. So when you map over a hash, that just returns like arrays with two elements, key and value. And then I sort that by the length of the second thing. So what this does, can I do that? Yeah. So this is like, oh, at index 2, you can only have arrival location. At index 17, you can only have arrival location in class. 18, you can have arrival location, arrival platform, class. So that tells us, by sorting it, it makes it easier to basically like process them one by one. Because what we want to do is like say, okay, this index, there's only one thing that can be at that index. And so it's at that index. And then we remove that thing from the consideration of all the indexes afterwards. Do I ever use this? No. So then I get my ticket. And then the final like actual question is, look for your 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? So I get my ticket, and then whenever I assign one of the departure rules to an index, I'll just right at that point reach into my ticket, get its value, and add it to this product. So then I loop over all the index potential rules, which is this key value pair of like the index and the rules that could, or like the fields at that point, and then an index just of where I am in this array, so I can remove stuff from everything after. If the rules, potential rules or potential fields, yeah, whatever. This should really be fields, but that's fine. So if there's only one potential rule, that's great. We pull it out, convert the set to an array, index 0. If the departure rules include that rule, then we look into my ticket, and this means that there's only one valid rule for that index, and so that rule is at that index. So we go into my ticket at that index and add it to our product. And then for all of the remaining things, for all the rule sets, we delete the rule that we just assigned. Yeah. And then I have this error that says like, hey, there are too many choices for this index. We don't know what to do. But Eric was nice enough, made sure that that sort of thing wouldn't happen. Very nicely constructed puzzle. Yeah. So where's my last puts? Boom. So that runs pretty quickly. Yeah. So that was day 16. I got 913 and then 2345. Leaderboard was 644 and then 2103. So just a couple minutes faster on part 1, which would have, okay, yeah, would have gotten me to like 735, which would have been very close to the leaderboard. Then I would have been very close to the leaderboard for part 2. That makes sense. I'm pretty satisfied with this. Wow, 9 minutes, amazing. Yeah, that was a great question. December 16th, 2020 solution. Boom. Cool. That's Advent of Code, day 16.